Hello, welcome to Tekla TEDDS 2024 course. Okay, so in this course, I'm going to analyze this beam. Okay, this is a strength of material by Rajput. Okay, this is example 4.7. Okay, so I'm going to get the shear force and the bending moment diagram of this example problem. Okay, to achieve that, now I'll come to my Tekla TEDDS. Okay, I'll create a new document. All right, so I'll go to my analysis, beam analysis. Okay, let me use beam analysis to Eurocode. I'll click on calculate. All right, so in this window now, okay, I'm going to be working from left to right. Okay, the first thing I'm going to do is to define the geometry of the beam. Okay, so to start with, I have to select a material for the beam. Let me go with concrete. Okay, so the name for the beam, I'll just call it member, or I can just say example 4.7. All right, I can come back to my strength of material by Rajput. Okay, the length of the beam is 1 meter, 1 meter, 2 meters, 1 meter, 1 meter. That is 6 meters. All right, so I'll come here and type 6 as the length of my beam. I'll select the default section for the beam. Okay, let me say 200 by 300. I'm not going to be using the section properties. I'll click OK. Okay, the support system for the beam is pinned here and also pinned here. So I'm going to go with pinned. Okay, and let me use roller support. Or let's go with pin in both directions. The result will all be the same. So I've defined the properties. I'll go to the loadings tab. Okay, so I don't want to include the self weight of the structure because I'm just running an analysis. Okay, I'll come to member loads here. I'll click on point loads. Okay, so I'll come here. Member is example 4.7. I'll be using imposed loads. All right, so I'll come here. Instead of using ratios, I'll use absolute length. Okay, so the first load is at 1 meter. The first point load is at 1 meter, while the last point load is at 5 meters. So I'll type 1 meter here, and the value of the load is 1 kilonewton. So I'll type 1 kilonewton here. I'll add another point load. I'll also use imposed at 5 meters. I have 4 kilonewton. Okay, so my loads are in the global Z direction. Okay, I can decide to use the local Z direction, but I'm using the global Z direction for my loads. Okay, so after defining my loads, for point loads, I can come and define uniformly distributed loads. Okay, so you can just add a member. This is example, my member is example 4.7. I'm going to be using imposed. Instead of ratio, I'm going to be using absolute. What should be the start position? Okay, it should start from 2 meters and ends at 4 meters. So I'll come here, type 2 meters and 4 meters. Okay, I don't need this extra load, or delete it. I'll move here. The value of the load is 2 kilonewton per meter. So I'll come here and will type 2, and it will be applied in the global Z direction. Okay, if I come back to my geometry, come back to my loading, you can see that my 1 kilonewton had been applied, my uniformly distributed load had been applied, and my point load of 4 kilonewton had also been applied. I'll go to my load combination. Okay, you can generate load combination automatically, but since we are just doing analysis, I'll just click on add. Okay, I just want 1.0 times the imposed load. Okay, so the factor for the self weight, I'm not using self weight, I'm not using permanent load, so the factor for the imposed load I will use 1. Okay, so if we are doing a live design now, okay, we can use the actual factors. Okay, here will be 1.6, here will be 1.4 for British standard. Okay, if it is Eurocode, here will be 1.5 and here will be 1.35 for Eurocode. Alright, so after doing that, I can come to the results. So this is my bending moment diagram. My maximum moment is reading 7.6 here. If I turn on my shear force diagram, okay, I'm having a shear force of 5.5 here and a shear force of 3.5 here. If you come back to the textbook, you can see that the maximum shear force here is 5.5 and the maximum shear force here is 3.5. The maximum bending moment here is 7.56. Okay, so if you come to the bending moment diagram and turn it on, okay, you can see that our maximum bending moment diagram is 7.6. Can come to my output. Okay, I can say let the input geometry be displayed as sketch. Alright, let the loading also be displayed as sketch, not tables. I don't want result for deflection. I don't want result for reactions. I just want result for the element end forces in tables, shear force and bending moment in both tables and sketches. I can click on OK. So this is my geometry, this is the loading, and if I move down, this is my result. My shear force to the left is 3.5, to the right is 5.5, and my maximum bending moment is 7.6. And if I go back to my textbook, you can see that this is approximately 7.6, is 3.5, and this is 5.5. Okay, so that brings us to the end of this part.